Thank you for coming today. My name is Melissa Dean, and welcome to our event about chemical engineering at LSU. We are excited to have y'all here today and excited to have you come to LSU in about a month. We hope that this event will help answer some questions that you couldn't have answered during orientation. So feel free to ask any and all questions while you are here. Today we have Barry Guillory with us. He is the main program advisor with chemical engineering. He is wonderful to work with. He'll give you a very thorough presentation on the department and curriculum. So at this time, please give him all your attention. And if you have questions, feel free to list your questions in the chat room. I will be monitoring that along with our current students. So with that, Barry, the floor is yours.
Thank you, Melissa. Welcome, everybody. I'm very happy to be talking to you today. So we're going to talk about the LSU Chemical Engineering Department. And here's our photograph of our building we're very proud of, Patrick F. Taylor Hall. We'll talk about that just a little bit more in a minute. So first of all, let me just say congratulations. Just the fact that you're interested in engineering and specifically chemical engineering, it's a very good decision. It makes for a great career. It's a career with a lot of opportunity to solve a lot of the problems that are facing the world. And I think if you stick with it and if you like math and science, you will really enjoy it. And chemical engineering, like the other engineering fields, have a very strong emphasis on mathematics and physics. So if you did very well in those topics in high school, you'll probably do well in engineering. But chemical engineering is a little bit different than the other disciplines in that we focus more on chemistry. And that gives us the opportunity to solve some problems that are specific to the mix of the chemistry along with physics and mathematics. Let me talk to you just a little bit about myself briefly. So I am not a career academic. I did go to LSU. I'm from a small town in Louisiana, like probably many of you. I'm from the town of Ville Platte. It's right in the center of Louisiana, about halfway between Lafayette and Alexandria. At the time, I thought I had a really good high school education, but once I got to LSU, I found out, no, it really wasn't that good. So I had to do a lot of catch up once I got here. I wasn't able to go directly into Calculus 1 directly out of high school. I expect many of you will be able to do that. But anyway, after a lot of hard work, I recovered from a weak high school education, and I did finish in 1983 with a bachelor's and then with an MS in 1984. I worked for Dow Chemical for 32 years, designed a lot of different chemical plants in a lot of different locations around the world. Let me see, I feel very fortunate to have my education from LSU and also very fortunate to have worked for Dow Chemical. Dow is a really great company. I mean, there's a lot of great companies in Louisiana, but Dow is one of them. If you get an opportunity to work for them, I recommend it. I was able to travel to many parts of the world. I lived in different places of the world, in Europe and the Middle East. So, you know, if it wouldn't be for LSU, I probably would still be in that small town in Louisiana. So I'm very thankful for that. I was able to lead one of the projects at Dow that we constructed the biggest chemical complex ever built. I retired from Dow and began work at LSU in 2017. So I teach here at LSU. I teach the design classes, which is very similar to the work that I did at Dow. So here's an overview of our discussions. So we're going to talk about chemical engineering at LSU. We're going to go over the flow chart, give you a few tips. We're going to talk about scholarships. Really, I think the secret is going to be your breakout session with these other students. We have 4 students, some of our best students here at LSU in chemical engineering, and it's a really good opportunity for you to learn firsthand from some of their experience going through the program. We're going to talk about some opportunities that you have if you finish the program, some post-graduation options, and maybe the average salary that you would expect from completing the program. Okay. Feel free to interrupt me at any time. If I hear something, I'll just pause and let you ask your question, or you can hold your question for the students at the breakout sessions at the end. You also get an opportunity at the end. I'll give you my email address. If you want to send me questions through email, that would be fine too. So I'm going to talk just about a little bit right now about what chemical engineers do. Primarily, they make stuff. You know, if you compare like chemical engineers to mechanical engineers, we don't assemble things. We don't put mechanical parts together. So we don't assemble like TVs or cars. What we make is the materials that go into those. So if you've been around Louisiana, you've probably seen some of the manufacturing facilities, like the photograph in the lower right here. They're typically up and down the Mississippi River. Those plants are extremely important to the world's economy. A lot of people don't realize it because they're not chemical engineers, but the world economy would totally break down if it wouldn't be for the materials that are made in those plants. And let me say, it's the chemical engineers that are the leaders in keeping those plants operating. Here's some examples, you know, plastics, medicines, fuels, and chemicals. We team up with chemists. We're different from chemists. So the chemists work on a lab scale. They'll develop the molecules of the products that are important. And once that compound or that molecule is developed, it's the chemical engineers that take the leadership role at producing those products on a scale that's needed. So the chemist will work on a lab scale, and then the chemical engineer will make those same products on a world scale, making sure they're available and produced safely and on a scale that makes it available to the world population. Just some examples of the things the world needs, you know, clean water, energy, food, medicine, clothing, housing, and transportation. Chemical engineers are involved in all of these products. You know, for example, clean water, really important today. You know, there's some processes that remove the salt out of ocean water to make it fit for drinking or irrigation. Energy is really important today. Chemical engineering is involved in every aspect of the energy business, either if it's fuels, the battery technologies, or for example, insulation materials that make it efficient to heat and cool our homes. The food industry, you know, we're always been involved in pesticides and insect control, or we're also involved in developing seeds to make better food products. You know, related to clothing, you know, if you're wearing cotton right now, it's probably not made by a chemical engineer, but most other fibers are. Any synthetic fibers were probably produced with the help of a chemical engineer. You know, transportation and housing construction, you know, most of the products that you would see in your house were made out of chemical engineering materials. You know, unless it's a natural fiber like wood, but any of the paint or the coatings that you see on the wood or the plastics that are in houses, all produced by chemical engineers. So in summary, we produce products that are important in the world. And while we're doing that, we minimize the environmental impact and protect the safety of the communities and the employees that are working in these plants. These products are made in these facilities, and there's a lot of these have a lot of dangers associated with them. Dangers to both society from an environmental perspective and from a safety perspective. Well, it's the chemical engineers that take the lead on running those operations with minimizing the environmental impact or the safety to the communities. So just after graduation, what could you do with the degree? Well, the majority of our students, our BS graduate students, go into manufacturing. This is a really important thing for not only the global economy, but for the Louisiana economy also. This slide shows the states across the U.S. and shows the value of their chemical production. You can see in 2010, Louisiana was number 3 out of the 50 U.S. states with $58 billion behind Texas and California. So really, Louisiana is a chemistry powerhouse compared to other states, especially when you look at the fact that Louisiana only has 5 million people. California and Texas have 30 and 40 million people respectively. So this is a good state to be a chemical engineer in. That's one of the reasons it's really popular for Louisiana people, is that if you want to have a really good job and you want to stay, and you're from Louisiana and you want to stay close to your family and your friends, you can do that with chemical engineering. Another thing that students do, they go into a consulting firm. So a consulting firm is different from a manufacturing firm. So a manufacturing firm may be like Dow or Exxon or Valero, some of those on the screen there, but a consulting firm may be like Jacobs Engineering or Fluor. They don't own the plant, but they offer their services to a manufacturing company. So if you're working for industrial manufacturing, your office will be in the plant. And if you're working for a consultant, your office will probably be in a downtown city area and it will be outside the plant. You may need to travel to the plant sometimes, but not on a daily basis. Another thing that people do is a lot of students end up going to graduate school. We have about 7% of our students that do that, become master's or PhD chemical engineers. A lot of our students also go to medical school or law school. We have a really popular discipline for both of those, especially if you want something like patent law. Some people go into government. So that could be something like NASA, or it could be something like the environmental protection agencies like EPA or DEQ, or the military. You know, our graduates are really popular with the nuclear and Navy. Just a little bit, I want to talk just a little bit about the manufacturing jobs in chemical engineering and what do you do in those roles. So if you go into one of these manufacturing roles, what you'll see is that those plants are really complex. There's a lot of parts to them. There's thousands or maybe millions of parts in each one of those plants that need to continually operate. And those plants, they're so expensive, we operate them 24 hours a day, 7 days a week. And what we find is there's always something malfunctioning. Not big things, but on a daily basis, there's something that malfunctions or breaks. And what our chemical engineers do is they take the lead on resolving all the issues as they come up. So you may have a pump that is not operating correctly, or there's some few photographs. You may have a tank that failed. Well, you would be responsible to investigate, to look at the evidence. Could be photograph, it could be data, determine what happened, and make sure that it doesn't happen again. So you're really the technical leader in those facilities. This is a video that shows what happens or what could happen if you do a bad job with respect to safety. So this tank is a chlorine tank. It's a tank with liquid chlorine in it. There's actually a couple of these types of plants within 20 miles of Baton Rouge. So you would be responsible to make sure something like this never happens. This tank is we're just opening a valve and releasing the content of that tank. But if this actually happened, anyone that would be in this area where this yellow cloud is, it would be a fatality. You would probably not survive this incident. So there's a lot of science and technology to make sure something like this never happens. And if it does happen, to minimize the environmental impact and the safety impact. Let's see. This slide talks about one of the awards that we won in 2020. The LSU Chemical Engineering Department won this award. So we have a really good program. We're fortunate to have it at Louisiana State University. There's about 160 chemical engineering programs in the United States. This particular award was given to the universities based on the salaries that their bachelor students attain at graduation. So if you look at a lot of the awards that are given to university programs, a lot of them are based on people's opinion or popularity contest. This is not that way. this is our customers, the people who hire our graduates, ranked us based on salary. So some of our graduates here at LSU are some of the most valued in the US, actually number 9 on the list. This is some more salary data. If you're looking at other engineering disciplines within LSU, this just compares some average data based on some 2018. So chemical engineering was the highest paid discipline, quite a bit higher than many of the others. We're 20% higher than the average of the College of Engineering, and we're also 23% higher than the average industry engineering degree on the US basis. So again, if you follow through, it's a good decision. So that's all the good side, but on the bad side, it's really difficult. So this may be something you want to ask these other students in the breakout session. It's a very difficult. You will find that you will have to work hard, and your social life will not be as good as people attending LSU in other fields. So be aware of that at the beginning. This slide shows the average number of graduates. You can see on the last 10 years, we've had quite an increase. This grayish bar in the back shows the total number of graduates. Within the last 4 or 5 years, it's varied between 100 and 140. It also shows the breakdown of male to female graduates. And you can see we have a lot of female graduates that have been very successful in our field. This slide shows the flow chart, the chemical engineering flow chart. I'm not going to go over it in detail. It's hard to do in a meeting like this. You're welcome to ask the students after in the breakout sessions anything about the flow chart in the classes. I will just hit it at a high level. You can also send me questions if you have questions about the flow chart through email. So the first 2 years are mostly math and physics. You'll take 1 or 2 chemical engineering courses, but really heavy on the math, chemistry, and the physics. In the second 2 years, you begin a lot of the engineering topics that are built on top and layered upon the math, chemistry, and physics. And after that, you're ready for a great career. Just a couple of points I wanted to make. The classes are contiguous, so it's important that you take them in sequence. And if you get behind, it's very hard to catch up. You can catch up sometimes in the summer, but it's difficult because not many of the classes are offered in the summer. Also be aware that many of the classes require C or better for you to continue on with the subsequent classes. So pay attention to your GPA. It's really important. The 2 most important things to getting a good job are your GPA and an internship. This slide shows a picture of our undergraduate laboratory. So this comes into play in your last 2 years in your chemical engineering studies. In your first 2 years, you're doing a lot of math, physics, chemistry, a lot of theory. Then you get into your engineering classes. And this room here, I know you can't see it very well, but inside this room, we have a series of modular experiments that the chemical engineering students complete. And then they take data, they run these experiments themselves, they take data and they compare it with the theory that they've learned in other classes. We're really proud of this laboratory. Here's a few of the experiments. We have absorbers where we remove contaminants from liquid or vapor streams. We have a bioreactor. We have a crystallizer. We have several other reactors. We have some experiments that are simulated purely on software. We have liquid extraction. So I think our laboratory would compete with any laboratory at any other university globally. Just a few comments on scholarships. We have a lot of scholarships available for chemical engineering students. And this is above and beyond the top system that many in Louisiana have already gotten. And here's some of the important criteria. 2171, that's chemical engineering 2171. That's your first major class, and it's a really important class. And usually the criteria is C or better in that class. It's really important that students do well in that first chemical engineering class. You typically need a 3.0 overall in your chemical engineering courses and a 3.0 overall on your LSU GPA. A minimum of 1 semester at LSU and be full-time. And some of the other criteria. And here is a list of all of the scholarships that we grant every semester. So there's a lot of that available, a lot of financial aid. I have a link here that is available. It's really just, how do you apply for these? Well, they're just one application. You apply one time at the College of Engineering, and once you put your application in, it qualifies you for all of these scholarships. This next slide talks about the co-op and internship program at LSU. We have a really big focus on that because we find that this helps students the most. This and the GPA are the two most important things for landing a really good first job. So we partner with the Career Center at LSU. We have a lot of the employers come and do face-to-face interviews. I understand this semester it's going to be remote, but the Career Center is going to try to make it as personable as possible. So I would encourage you all to take advantage of that. There's typically 2 career fairs a year. And that's it. Here's my email address. You're welcome to write it down. Send me an email if you have questions. Let me pause here for a second. See if anyone has any questions. And as soon as I finish with your questions, we'll go to the breakout sessions. And you'll get the students' ability to answer questions also.
Any questions for Mr. Guillory before we wrap up with the recorded portion? Okay, awesome. Well, thank y'all so much. I'm going to stop the recording now. And if you have any questions, again, this is Barry's email address. And if you have questions for me, my email is mhart3@lsu.edu. And we would be more than happy to answer any questions after this event.
Thank you.